Hello everyone, welcome back. I am Vijay and today we are going to learn how to control the speed and the direction of DC motor using a motor driver LN298 and an Arduino. It's a very fundamental skill for many robotic projects and a bunch of other exciting applications. So let's get started. Controlling the speed and direction of DC motor is a very common practice in robotic applications and a motor driver is needed to achieve this. We'll need Arduino, a breadboard, a brushed motor, L298 and motor driver, a 6-volt battery pack, or a adapter, a potentiometer, and jumper cables. To begin, let us take a DC motor, 6-volt battery pack, and potentiometer to understand what is the necessity of motor driver. Let us add a potentiometer between two terminals of battery pack as shown in the figure. Now we can check the voltage we are getting across the extreme terminal of the pot and across reference terminal and the middle terminal. We see the voltage varies from 6.5 volt across the extreme terminal to 3.3 volt and 4.4 volt across the reference and middle terminals based on the pot knob positions that I am changing. Let us now connect the motor to 6 volt supply through potentiometer by connecting the middle terminal of potentiometer to regulate the supply voltage as connected in the setup. We see the shaft rotates and its speed changes if we regulate the supply through potentiometer. Once we reverse the polarity by changing the jumper cables, it will cause the shaft to rotate in opposite direction. And speed changes when we regulate the power supply. The direction of a DC motor is simply a matter of reversing the polarity of the supply voltage applied to it. The most common method of doing this is to use a design called an H-bridge. The operation of an H-bridge can be illustrated using 4 switches arranged in the configuration shown here, and this configuration is resembling the shape of H. The motor will receive no supply when all switches are open. If we close 2 of the switches as shown, then the current is allowed to flow through the motor and the motor rotates in one direction. And now, in case we open these switches and close the other 2, the current flows in opposite direction, causing it to rotate in opposite direction. In the real world, we will not use the switches but use bipolar transistors for switching. Bipolar transistors have a potential drop of 0.7 volt between the emitter and collector when they are switched on. The total drop is about 1.4 volts as we are using 2 of these simultaneously in the motor drivers. This means that if we apply about 6 volt to the H-bridge, the motor will actually receive approximately 4.6 volts if we are using L298 and motor driver. You can also see that when we supply 12 volt to H-bridge, motor will receive approximately 10.6 volt and so on. The energy lost is converted into heat, and that is why bipolar transistors require heat sink that we just show. It is important for any driver to be able to handle motor operating voltages and average current, which we find in the motor datasheet. The driver also needs to be able to have a peak current capability to handle the stall current of the motor. The L298N, as we are talking from the beginning, is one of the most versatile dual full bridge motor driver chip. It's designed to drive inductive loads such as the relay, solenoid, DC and stepper motors. We can see the heat sink that is sitting on the chip for heat dissipation. You can see 3 screw connectors on this module. On the back side of the module, these are marked as 12 volt, ground and 5 volt. And this 5 volt is the logic input. There is a strap on the board, and when we connect the strap in, then the logic voltage is provided by motor supply. An additional supply input is provided so that the logic works at lower voltage. Just see the other two terminals for motor A and B, and we have to adjust these connections to get the desired directions for initial setup, and then we can control these. Here we have some more connections for the control that you see. So two enable input pins to enable or disable the device independently of the input signal. You can also find two steps on enable A and enable B. When these steps are in, these keep pins high so that motor are always enabled. So when our application does not require to control the speed of the motor and we only want to control motor direction, we can just use these steps rather than any additional connection from the Arduino to make them high. If you want to control the motor speed, however, pulse width modulation is applied to the enable pins. IN1 and IN2 control motor A, and IN3 and IN4 control motor B. We can use logic table for the signals. Let us open the data sheet of L298N motor driver to look at the logic table and other specifications as well. To understand this, let us first see the pin out of the chip. We see the input pins are pin 5, pin 7 for motor A, and pin 10, pin 12 for motor B. Also, enable pins are pin 6 for motor A and pin 11 for motor B. Motor A is connected to output 1 and 2, which correspond to pin 2 and pin 3 and controlled by enable pin 6. Motor B is connected to output 3 and output 4, which correspond to pin 13 and pin 14 and controlled by enable pin 11. We can see the circuit diagram and find that C correspond to pin 10 and D to pin 12 as given in the circuit, and that is corresponding to the logic table. So we can refer C as input 3 and D as input 4. Now coming to the logic table once again, the motor will rotate in the desired direction when enable A is high, input 3 is high, and input 4 is low. If we are not getting the desired direction, we can change the connection. We can also see from the data sheet that this L298N module can handle a motor voltage from 5 to 35 volt and can supply a continuous current of 2 ampere and the peak current of 3 amperes. We will set up various experiments to understand the various aspects of the module. So let us begin with running motor at fixed RPM. So connect the circuit as shown in the block diagram. The ground is set common with Arduino ground. External voltage is applied through 12 volt adapter. The digital pin of the Arduino D8 and D9 are connected to IN1 and IN2. The strap is kept on enable A, so it's always high. The strap of 5 volt logic supply is also on, so the logic voltage is supplied through the 12 volt external supply. So we need not to provide any separate 5 volt logic. The code is very straightforward. We define the both motor pins as D8 and D9 and in the setup as output pin using pin mode in the setup function. Use digital write to set D8 high and D9 low. Upload the code and see it in action. We can check the supply voltage and the output voltage, and we see the drop. That drop is observed as discussed, which is because of the drop across bipolar transistor, 0.7 volt across each transistor. If we remove the jumper of logic supply, the circuit becomes non-operational and the motor stops. Alternatively, we can connect to 5-volt supply as logic supply voltage through the screw connector. Now, next it is time to control the speed of the motor. For this, let us remove the enable A strap and connect the pin to D10 of the Arduino. And this pin has to be a PWM pin. Now we can demonstrate the effect of this by increasing the PWM output using a loop and then decreasing it using another loop. Then we change the polarity and repeat these blocks of increasing and decreasing. The step for the PWM can be set as per your choice. So we can upload this code and see this in Excel. This should give you a thorough understanding of why we need a motor driver for controlling the motor and how to use L298N. We can also control 2 motors from one motor driver, and here is how you should connect these 2 motors. I am sure now you will be able to write the code and have fun by changing the different directions and controlling the directions as well as the speed of these motors. That's all for this tutorial. If you found this tutorial helpful, don't forget to like this video and subscribe for more tutorials. Until next time, keep learning. Thank you.